Welcome back to Laugh and Code, the Elm Programming Show, where we dive into the vibrant and exhilarating world of Elm programming with a twist of humor and a dash of creativity. In today's episode, we're diving into one of Elm's superpowers, its type system. Elm's approach to types not only prevents a myriad of common bugs, but also serves as your personal coding assistant, guiding you towards cleaner, more reliable code. In Elm, playing with types is encouraged. It's like Legos, but you can't step on them in the middle of the night. Elm's type system is like the rulebook of a board game. It outlines what moves can be played and ensures everyone plays by the rules, resulting in a fair and fun game. In programming terms, this means that Elm checks your code for type correctness before it even runs, catching errors early in the development process. In Elm, there are three kinds of types. First, basic types. Just like in real life, everything has a type. For example, apples are fruit and cars are vehicles. Elm categorizes data into types such as int for integers, string for text, bool for Boolean values, and so on. Like I said earlier, there are three kinds of types, and all of those types have a type annotation. Type annotations are like name tags at a party. They make it clear who's who, so that you don't accidentally start a conversation with a string when you wanted an int. For instance, my age space int declares that my age is an integer. Imagine asking for a cup of tea and getting a sneaker instead. Elm's type system makes sure that you always get the tea. Specifically, type annotations ensures that that never happens. Diving into custom types, the second of the three kinds of types in Elm, think of custom types as the Lego blocks of Elm programming. Just as you decide whether your Lego masterpiece is going to be a castle or a spaceship, custom types allow you to tailor your data structures precisely to your needs. It's your coding world, a place where you're the master builder, piecing together the perfect structure to solve your problem. To see example Elm applications, go to elm-lang.org/try. I like to hit Ctrl+++ for a bigger font size. If we click on the cards example, we can scroll down to see that both the type card and the type MSG are custom types. Remember, custom types in Elm are like creating your action figure lineup. Whether it's a superhero squad or an assembly of mythical creatures, you're in control. If we scroll up to the model type, we can see that the model is not a custom type because it says alias. We'll cover that next. On to the third of the three kinds of types in Elm, type aliases, our coding shorthand. Imagine if every time you wanted to refer to your friend, you had to use their entire life story. Exhausting, right? That's where type aliases come in handy. They let you abbreviate complex types into something as simple as calling Robert by Bob. It streamlines your code and makes it more readable, like having a secret handshake with Elm that only you two understand. In the HTTP example, we can scroll down to quote to see an example of a type alias. In this example, the model is not a type alias because it doesn't say alias. Type aliases contain a list of type annotations enclosed in squiggle brackets, whereas custom types have a list of variants. The first part of a type annotation is the identifier. The second part is the type. In this case, the type is a basic type, string. Type aliases and custom types can also be the type. The main difference between type aliases and custom types is that in order to access the data within a custom type, pattern matching is required. Here's an example of pattern matching of the custom type MSG right here. In order to do pattern matching, we say case MSG. This is lowercase because it's the identifier. And then we list each of the variants. We will cover this in more detail and also see that pattern matching can be applied in other ways. Let's embark on a tune through Elm's domain of types, a trio of kinds of types, each with its unique stripes. In Elm's realm, basic types lay the ground. Int, string, bool, in simplicity they're found. But for names that stretch beyond the bound, type aliases simplify, come what may. Custom types for patterns, a display so fine. In Elm's kingdom, in elegance they entwine. Though from different molds, together they shine. In Elm's tapestry, all types align. In Elm, there are three kinds of types: basic types, type aliases, and custom types, and they all align within a type annotation. Now, it's your turn to give it a try. Craft a custom type for your favorite hobby. Is it reading with genres your variants? Is it gaming with platforms and genres? Or maybe coding with languages and frameworks? Jump into the Elm Online Editor to sketch out your custom type. Share your creation in the comments below or on social media, like GitHub. Let's see the diversity of hobbies and how creatively they can be represented in Elm. Hint: start with the cards example. Pause the video and try to complete the challenge before seeing my solution. We will start off with the cards example. When creating or updating custom types, there are three places to look for changes: in the model, in the update, and in the view. In the view, we can see cards are used here in the view card function. In the update section, cards are here and here. And in the model, there's the definition of card and the initialization of the card within the model. I'm going to replace card with gaming platform, which is either PC, console, or mobile. First, let's do a text replace of card with gaming platform. So I'll just copy all of the text to a text editor and do a find and replace for card. Find and replace, look for card, and replace it with gaming platform. Next, I'll update the type definition for gaming platform. The variants for a gaming platform are PC, console, and mobile. Then, I'll update the random function. In this card example, there's a draw a random card function, so we'll have a draw a random gaming platform function. So it's PC, console, and mobile. Finally, I'll update the view function. So each of these pattern matching has a pattern that it matches, so it has to be one of the variants. So it'll be PC, console, and mobile. And then it results in a string. And so the return value of the pattern matching has to be the same type for each pattern. And so in this case, it's a string. So I'll just have it the text version of the variant. Then we can click rebuild to see if it compiles. And we have an error. The error is because when we did that find and replace earlier, we weren't careful to make sure that all types are capitalized and all identifiers start with a lowercase character or an underscore. That's a requirement in Elm. So I'll just make sure that all these identifiers are lowercase. And also in the initialize function, there needs to be an initial value. We'll give a PC value, and on line 74. And also the first item of this list in the random gaming platform generator has to be outside the list here, because that's also the default value. So this should be PC, and PC should not be in this list. And the other error is on line 63 here. This should be lowercase because it's this function being passed as a value to this other function. We'll cover things like this later on. So here's the example running, PC, mobile, and we're drawing mobile consecutive times, console. So we saw all three values. So going over the program, it started off with the type definition of the gaming platform. We initialized it in the model. Then there's some messages and update functions that utilize this gaming platform generator to randomly generate one of the three gaming platforms. And once those are generated and stored in the model, then they can be viewed with this view gaming platform function with these three variants. As we close this chapter on playing with types, I hope you've enjoyed this as much as a cat enjoys a box slightly too small for it, because we've only scratched the surface of Elm's potential to simplify and enrich our development experience. In our next episode, The Magic of Functions, we'll step into Elm's Hogwarts, where functions are our spells and type safety is our wand. If you thought custom types and aliases were game changers, wait until we start casting functional spells. Make sure to subscribe, share, comment, and like if you're ready for more headache-free coding adventures. Until next time, happy coding!